So remember, the maritime polar originate from polar regions, for example, Canada, Greenland, and Antarctica. The air mass is cold but carry large amounts of moisture. If this air mass moves over warm waters, they may become unstable, which can produce torrential rainfalls. Now let's move to the maritime tropical, which is the fourth air mass. So maritime tropical air mass originates over oceans within 25 degrees latitude, both north and south of the equator. They are associated with warm, humid conditions and high dew points. So most of the thunderstorms that occur in the US, they develop in the presence of maritime tropical air mass. So maritime tropical air mass influences the US more during the summer than during winter, and exert the greatest influence in the southeastern states. So they originate in oceans and seas from the tropics, for example, over the mid-Atlantic and North Indian Ocean. They are warm and therefore they carry large amounts of moisture, therefore bringing rainfall in their way or their path. So a good example affecting Zimbabwe is the Zaire air, which migrate from the Atlantic and picks moisture from the surrounding rainforest in Congo and joins with the ITCZ over Zimbabwe. Now, this marks the end of our types of air masses that we have. So remember, we talked about the characteristics of the air masses, and we talked of their origin and source, and then we looked into the types of air masses, where we talked about the continental polar air mass or polar continental air mass, and we said they are cold and dry, originating from high latitudes, typically as air flowing out of the polar highs. And we talked about the continental tropical air mass, and we said these originate on land from the tropics. They are warm and dry, little or no moisture, originate mainly from arid regions, for example, Sahara regions. They bring the hottest and driest conditions in their way. And then we talked about the maritime polar air mass, where we said it originates from the polar regions, for example, Canada, Greenland, and Antarctica. And the air mass is cold but carry large amounts of moisture. And if the air mass moves over warm waters, they may become unstable, which can produce torrential rainfalls. And then we have the maritime tropical. We say that these originate in oceans and seas from the tropics, for example, over mid-Atlantic and North Indian Ocean. And they are warm and therefore carry large amounts of moisture because therefore they bring rainfall in their way. And a good example, we talked about this Zaire, which migrate from the Atlantic and picks moisture from the surrounding rainforest in Congo and then joins with the ITCZ in over Zimbabwe. Now let's look into the characteristics of the types of air masses. So with all this information now, with the characteristics that these air masses have and their origin, we should be able to have or describe their characteristics. So air masses maintain characteristics of their source or origin. Now, areas where an air mass originates from are known as the air mass source regions. So air masses originating from oceans are usually warm and moisture. For example, the southeast trade winds, which originates over the Indian Ocean. Air masses which originate from deserts are hot, dry, and dusty, such as the Harmattan winds, which originate from the Sahara Desert. Air masses are modified by the surface over which they pass, and their later properties will also depend on the nature of the surface they pass over, in addition to their source region characteristics. So we're saying they already have a characteristics that they have carried from the source region, which gives them a different lesson. For example, the polar air mass. So it is taking the polar characteristics and then carries them. But when they pass over different types of, like maybe land or water, they adopt or they become, right, the properties of the places or the nature of the surface that they will pass over. So air masses are named from the direction in which they blow. Air masses blow from regions of high pressure to regions of low pressure. So now we're going to then move into the formation of fronts or boundaries. So